Okay, this is the second video of the day. This is part 2 of our formulas on area. We're dealing with composite shapes and areas in the coordinate plane. This is day 3 information. So we're going to kind of continue what we were doing last time. We've already talked about composite figures and what they are, so let's just do a little tougher problems, right? What do I need to do to find the area of the shaded region here? Well, the first thing you just need to ask, listen, is this kind of like an addition problem or is it a subtraction problem? And to me, this looks like a subtraction problem. When I look at this, I say, you know what I could do? I could find the area of this gigantic triangle here, and I need to take away then the area of the whole, right? So let's take away, let's do the area of the triangle minus the area of the circle, and that should give us what's remaining. That should be the shaded portion on the outside, right? Well, here's what I need to know. The area of a triangle is 1/2 times base times height. What's the base of this triangle here? I see that it goes 36 units all the way across, right? So that's 1/2 times 36. Now the question is, how tall is the triangle? Well, I'm not given that dimension, so I got some work to do, right? Here's one way that I might approach it then. Notice that each side of the triangle, it's a right triangle, so I'm going to look at just this piece, and it's a right triangle. And the height, let's just call the height h. So this h here represents the total from the bottom all the way up to the tip, right? And I can use Pythagorean Theorem here. So off to the side, I'm going to do something like this. 18 squared plus h squared is equal to 36 squared. I'm going to use Pythagorean Theorem to solve for how tall the triangle is. Okay, little rearranging. 18 squared happens to be 324. And 36 squared happens to be 1296. I subtract the 324 from both sides. I have 972. I take the square root of both sides, and I get 31.1769. So it's not a nice, neat number, okay? It's really, you know what, we can leave it in a couple of ways. We can say it's the square root of 972 for now. We could break that down, I don't know. Or we could just leave it as the 31.1769. It really doesn't matter. I tell you what, since I've been forcing you guys to go through and do exact answers on all these problems, let's go ahead and do that. Let's go ahead and do that. What is the square root of 972? So I'm going to look for a square that comes out of it. 9 and 7 and 2, that's 18. 18 is divisible by 9. You know what? 9 is going to go into that. I don't know how many times, but it will. So here we go. Sidestep, going a little tangent here. What is the square root of 972? I know that the square root of 972 is the same thing as 9 times 108. 108 is also divisible by 9. So 108 divided by 9, that would be 9 times 12. And I know that that's actually 12 is 4 times 3. So getting close. So I've broken that down. Just keep dividing it out, rewriting it, right? So the 9 goes here. 108 is 9 times 12. 12 is 4 times 3. So I just replace each part. That means that really this is the square root of 9 times the square root of 9 times the square root of 4 times the square root of 3. A few of those of which I know. That's really 3 times the square root of 4, which is 2, times the square root of 3. Right? 3 times 3 is 9. 9 times 2 is 18. That's 18 square roots of 3. So hey, you know what? It's 18 square roots of 3. Oh man, it's a 30, 60, 90 triangle. Son of a gun. Too bad I don't remember those, huh? If you remember your formulas there, that's a 30, 60, 90. The base is always half the length of the height of the long side, and to go from the base, the short side to the long side, to just tack on a square root of 3. I'll be darned. So you know what? This is 18 square roots of 3. This is going to help me find the area of the total triangle, right? So let's put that together. 1/2 of 36 is 18. 18 times 18 square roots of 3 is really 324 square roots of 3. How did I get that? Because I multiplied 1/2 times 36 times 18 first, and that got me to 324. Now I got the square root of 3 that I just don't know what to do with, right? So this number here represents the area of the triangle. Now we need to find the area of the circle. The area of a circle is just pi r squared, so let's do it over here. Sorry about the messiness here. I should have planned this out where I was going to write stuff first. Area of a circle is pi r squared. It looks like the radius is 6 centimeters. So that's pi times 6 squared. which is just 36 pi, right? So I'm not adding together, I'm subtracting away, right? I'm going to take the triangle and subtract away the whole. That means the area exactly is this. The total area of the shaded region, which is the triangle minus the circle, is 324 square roots of 3 minus 36 pi. That's exactly what it is. Oh, you know what I didn't do? Square centimeters. Now, if I did it in decimals, if I was okay with an approximation in this problem, which I guess you're probably sitting there going, man, I hope he lets us approximate. It's 324 times the square root of 3. It's really 561.18446 minus 36 pi, which is about 113.0973. It's about 59, almost done. It's about 448.09 square centimeters. So there would be an approximation. A lot tougher, right? It took me 6 minutes just to get through that problem and 5 minutes to go through all of the examples in the previous video. Let's do a couple of quick ACT examples. These are actually straight off the ACT. Looks tough. This problem looks tough, but it's a lot easier than you think. What's the area of the shaded triangle? Here's what I need to know. I don't care about this portion here. Here's what I need to know for the triangle. Area is 1/2 times the base times the height, right? What's the base of the shaded portion? See, that's 8 feet total, and there's 2 feet here. Doesn't that mean that there's 6 feet between these 2 points? So that's a 6. How tall is the triangle vertically? 6 feet. I don't care that it's outside. It doesn't matter whether it's obtuse or acute or a right triangle. It's just how tall is it vertically, right? So the area is 1/2 of 6 times 6. 6 times 6 is 36. Half of that is 18. It's an ACT problem, folks. It's made to where you don't need a calculator, okay? Don't overthink them. Here's an example of, okay, now listen. What is the area of this figure in square inches? What is the area of the figure in square inches? So there's a couple of ways to do this problem. I think the easiest way is just to look at it this way. Ready? Let's break this up into 3 shapes. This would be a 5 by 13 rectangle. Okay? And if you take 5 times 13, you get 65. This is a 1 by, it's not 9. That would be tricky, really. Here's 3, right? So that means that this part is 6. The rest of the 9. It's a 1 by 6. That's a 6-unit rectangle. This is 4 by 3. 4 times 3 is 12. And so I just want to add them together. 65 plus 12 plus 6 is equal to 83 square inches. One more. And the figure below, a square is circumscribed, blah, 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 blah. You know what? You can read through this if you want to. This is important. 30-inch diameter. That means the distance, say, from here to here, total is 30 inches, right? Points A, B, C, and D are the midpoints. So in other words, if it's 30 total, that means it's 15 from here to here, and 15 from here to here, and 15 and 15, so on and so forth. What is the total area in square inches of the shaded region? Now this looks awful. It looks like you're going to have to do a ton of work, but I want you to notice something. See this little cutout right here? The shaded region? What would happen if I took this and plus, you know what if that was shaded instead? Oh look, you know what? That's a 30 by 30 square. The area of the square is 900, 30 times 30. And you know what? I want 1/4 of that, don't I? What is 1/4 of 900? 225. Man, that is a deceivingly easy problem, isn't it? So there's just a few examples. That's the second video that we have. I got 2 more, it looks like. They should be pretty quick, I hope. This is definitely the long one on area of composite shapes.